This section discusses the boiler components along with accessories for a hot water heating system. We will begin by looking at those components located on the boiler: the safety relief valve, the boiler gauge, the limit control, and tankless heaters. All hot water boilers must have a safety relief valve. The safety relief valve is used to protect the boiler from excessive pressure buildup. This valve is set to open and discharge water when boiler pressure reaches a set point. For most cast iron residential water boilers, the pressure relief valve is set to discharge at 30 psi, pounds per square inch. These valves should be piped to within 6 inches of the floor to avoid the possibility of hot water being discharged on anyone. The boiler gauge measures both temperature and pressure. The gauge displays the boiler supply water temperature and the pressure in the boiler when the entire system is filled. These gauges are typically installed in a tapping near the supply outlet on the boiler. Limit control switches are designed to react to the changes in water temperature. Most limit controls have an adjustable high limit setting with a 10-degree fixed differential. The high limit setting is used as a temperature protection device for the boiler. If the boiler water should reach the high setting, the limit switch would cause the burner to shut off and stop producing heat. The circulator continues to operate, removing heat from the boiler and distributing it to the terminals until the water temperature is lowered to 10 degrees of the fixed differential. Then, if the thermostat is still calling for heat, the burner would again fire. For example, if you set the high limit for 200 degrees Fahrenheit, then the burner will shut off when the water temperature reaches 200 degrees Fahrenheit. When the boiler water temperature falls to 190 degrees Fahrenheit, the burner turns back on and continues heating the water until either the water temperature reaches 200 degrees Fahrenheit or the thermostat stops calling for heat. Some boilers are equipped with a tankless heater, which supplies domestic hot water for bathing, clothes washing, and so on. The tankless heater is a long piece of thin copper tubing wound into a tight coil, and it's typically located in the upper nipple port. The tankless heater uses the heat stored in the boiler water to provide domestic hot water, thereby eliminating the need for a separate water heater. Tankless heater ratings are based on the ability to raise the domestic water temperature from 40 degrees Fahrenheit to 140 degrees Fahrenheit when the boiler water temperature is 200 degrees Fahrenheit. When installing a tankless heater, the outlet piping should be connected to a mixing valve. The mixing valve tempers the hot water from the tankless heater with cold water to produce the desired temperature of domestic hot water. This not only increases the quantity of usable hot water, but can reduce or eliminate the possibility of scalding. To assure adequate quantities of domestic hot water, the tankless heater uses a special combination limit control, which consists of a high limit setting, low limit setting, and differential setting. As in all limit controls, the high limit is a protection device for the boiler, shutting off the burner when the boiler water temperature reaches the high setting. The low limit is used to maintain a minimum boiler water temperature. The higher the low limit setting, the greater the quantity of domestic hot water available. However, a high setting also increases the standby heat loss, increasing operating costs. This means the boiler is maintaining a high water temperature while waiting for a call for heat. Thus, standby heat is lost through the flue, boiler jacket, and piping. The low limit should be set to the minimum temperature, which provides an adequate supply of domestic hot water, and not less than 20 degrees Fahrenheit below the high limit setting. When the boiler water temperature falls 10 degrees Fahrenheit below the low limit setting, the burner is turned on. If there is a simultaneous call for heat, the circulator is turned off. This gives priority to the domestic water heating load. Remember from previous sections how a hot water system maintains a more even temperature in the heated space. The short time the circulator is off will not cause any noticeable change in room air temperature. The temperature where the burner is turned off, or if a call for heat where the circulator turns on, is determined by the differential setting. The differential setting is an adjustable setting. A 20-degree differential gives the boiler a 20-degree Fahrenheit range of operation. This is based on the low limit setting, and a 10-degree fixed differential below the low limit setting. For example, if the low limit is set at 160 degrees Fahrenheit and the differential is set at 20 degrees, then the range of boiler operation is 20 degrees, 10 degrees below the low limit setting, or 150 degrees Fahrenheit, to 10 degrees above the low limit setting, or 170 degrees Fahrenheit. The range of boiler operation would be 150 degrees Fahrenheit to 170 degrees Fahrenheit. A large differential setting will provide more domestic hot water and reduce burner cycling. However, the disadvantage is higher operating costs due to greater standby losses. Components and accessory items located near the boiler include the circulator, the expansion tank, air control fittings, and the fill valve. Most common residential circulators are single-stage centrifugal pumps located on the return piping of the boiler. The circulator's job is to create the pressure necessary to force water circulation throughout the hot water system. The circulator contains an impeller with a number of vanes which rotate at a high speed to force the water out of the circulator, through the boiler, and into the system. Circulators have two important ratings: pump capacity and pump head. Pump capacity refers to the amount of gallons per minute, GPM, of water the circulator can move. Pump head, or head pressure, is a measurement of how much pressure the circulator can generate to move the water in the system against existing system resistance caused by pipes, valves, fittings, and so on. Pump head is measured in feet of water. Both of these pump ratings have a relationship to each other. As pump capacity increases, head pressure decreases, or as head pressure or system pressure drop increases, the pump capacity decreases. This relationship is illustrated in the manufacturer's pump performance curve. So, when sizing the circulator, first determine the needed GPM for the pump and then calculate the resulting system pressure drop. Remember that the energy needed to raise 1 pound of water 1 degree Fahrenheit is a BTU. When sizing the circulator, calculate the water flow rate through the system. A gallon of water weighs 8.3 pounds. So heating 1 gallon of water 1 degree Fahrenheit requires 8.3 BTUs. Since the water in a hot water system is not static, but is forced through the system and is constantly reheated, think in terms of BTU production as gallons of water per hour. If 1 gallon of water provides 8.3 BTUs in a minute, then in 1 hour it would provide 8.3 times 60 equals 498, or 498 BTU-H. Since this number makes for more complicated calculations, the 498 is rounded to 500. Thus, 1 GPM of water produces 500 BTU-H for each degree rise in temperature. To determine the pump capacity, assume your system has a 20-degree temperature drop and multiply 500 BTU-H times 20, giving 10,000 BTU-H per GPM. Next, divide the total heat loss of the building by the BTUH temperature drop. From our first example, 58,280 BTUH total heat loss divided by 10,000 BTUH temperature drop equals 5.82 GPM needed pump capacity. To determine the pump head required, determine the pressure drop for the system. Pressure drop is the amount of pressure lost from the boiler supply to the boiler return due to friction from system piping and fittings. Pressure drop will increase if the water flow rate increases and the pipe size remains the same. Pressure drop will decrease if the water flow rate remains the same and the pipe size increases. Pump and heat terminal manufacturers provide charts for calculating pressure drop for sizing circulators with the appropriate pump head. As the water is heated in a hot water system, it expands. To compensate for this water expansion, the system needs an expansion tank. The conventional air cushion tank contains a cushion of air which is compressed as the heated water expands. Because the air and water are in contact, the water has the ability to absorb some of the air in the tank. In time, the tank can become waterlogged and have no air cushion left for the expansion of the heated water. When this occurs, the tank must be recharged with air. To prevent the tank from becoming waterlogged, there are a number of air control fittings available to be used with these tanks. The diaphragm air cushion tank has a flexible diaphragm that separates the air from the water. Since the air and water never touch, the water cannot absorb the air. These tanks come pre-pressurized or pre-charged with air. The diaphragm is large enough that it lays across the sides and bottom of the tank. As the system water is heated, it begins to press against the diaphragm, which compresses the air cushion, allowing for the expansion of the water up into the tank. It is very important that these tanks are properly sized for the boiler and heating system. Consult manufacturer for proper sizing information. Air control fittings are designed to be installed on either the boiler or air cushion tank and are used to release air from the system. Air in the system can cause water circulation noise in the pipes, along with slowing or stopping the water movement and damage to the circulator or boiler sections. An air control fitting directs the air into the air cushion tank. While McLean boilers do not require air control fittings because they have a built-in air eliminator within the cast iron, located next to the supply tapping of the boiler. The purpose of the air eliminator is to divert rising air bubbles in the boiler to the expansion tank or air vent. The fill valve is located in the return piping as close to the boiler as convenient. This valve is for adding water from the home water system to the boiler. There are a number of other important hot water system accessories to be aware of. These include air vents, flow control valves, and one-pipe fittings. Air vents are used at the high points of the piping system, usually installed on the terminal units, to release any air from the hot water. They are essential when installing and filling the boiler and system with water. The vent closes when water reaches the air vent. A flow control valve prevents gravity circulation of system water when the circulator is not in operation. The flow control valve allows system water to flow in one direction when the circulator supplies system pressure. These valves are particularly useful when the boiler is providing domestic hot water or feeding another zone when zoning with circulators. One-pipe fittings are used with one-pipe systems and are installed at the connection of the system main and the terminal risers. These fittings are used to divert the water to and from the terminals. In this section, we have discussed hot water boiler components and accessories located on the boiler, near the boiler, and in the system. These include the safety relief valve, boiler gauge, limit control switch, circulator, expansion tank, air control fittings, fill valve, air vents, flow control valve, and one-pipe fittings. In the next section, we will look at system piping for a hot water heating system. Please turn the videotape off now and complete section D in your workbook.